Hello, everyone. Thanks for joining our July's event. We're going to maybe give a couple of minutes to other folks. In the meantime, I'm just going to do some announcements. I really don't have that much, but what I wanted to show is our website. In case you haven't bookmarked it, this is the place where you can find, let me see if my screen is going to get shared. Yeah, I'm not doing this the right way. Okay. Okay, well, not going to be able to put the website on the page, but well, cltjog.org. That's the place where you can find all the information related, the link to the meetup, our meetup page, so that you can register there, be part of the community. Our Twitter handle, you can find it also there. I mean, if you're on Twitter, please follow us so you can be informed of the latest news. You can see the upcoming events there as well. And soon, which I've been promising for the last 6 months, we're going to have the previous events published there. Right now, we have a few on YouTube. Each one of these that we have been doing live are also showing up there. But I just want to have in the website just a consolidated view of all the past events so you can find them easily and you can share them. Also, if there's our contact details there in case you're interested in sponsoring the group, or if you are interested in giving a talk, feel free to reach out. Or if you have any ideas, how can we improve, any type of sessions that you're thinking about, anything that you want to learn that we can get a speaker to talk about, anything. I mean, this community we all make this community. We want you to be part of it, and even just by providing feedback of how can we improve, that's also good enough. We have a Slack org as well. I put a link to get yourself included in the meetup, but I'm going to add that same link in the website soon as well. Yeah, and don't forget, at the end of the presentation, we're going to take your questions. There's a slight delay in YouTube streams, so that's why we're going to collect your questions on the live chat, but Amanda will answer all your questions at the end. And we're also going to have our JetBrains raffle, 1 year license for a product, so stick around. That's all from my side. Abel?
Yeah, well, we're actually really happy and pleased to have Amanda today. Amanda is a solutions engineer with Confluent. She has been working in the data space for the last 6 years, and she has a lot of experience in event-driven architectures. So that's actually really cool from her, and we really appreciate her giving a talk today. She was actually presenting a talk in the O'Reilly Software Architecture Conference back in February. That's where I met her, and actually we were so lucky that we didn't get COVID that time. And also in her free time, Amanda enjoys playing poker. She's actually the founder of a local league of poker, if you want to reach out to her. So with that, I really want to thank you, Amanda, for doing this, and I will let it to you.
Awesome. Yeah, thank you. And I got to make a correction. I'm not a founder. I just play. But if you do want to come play with me anytime, you guys can reach out and I'll get you the details and get you set up once all of this passes, obviously. So
cool.
Let me know if you can see my screen. Let me share. make sure it's working. Good?
Yep.
Awesome. Okay, so today, everyone, my name is Amanda Gilbert. I'm going to be giving I'm calling it like a Kafka 102 session because it's sort of introductory plus, so introductory into Kafka, and then also a little bit more than that, so talking a bit about event-driven systems and also how to make certain architecture decisions when you decide to use and deploy Kafka in production. I do work for Confluent. I am essentially a solutions engineer, so I work with the sales team. I do a lot of like architecture work, some development work, but it's mostly on the architecture side. So looking at current applications, breaking them down, making them more efficient using a middle, like single source of truth layer that is Kafka and its surrounding ecosystem. So I'll start off by talking about event-driven systems in general and what they really look like, what the considerations are. They're asynchronous and they allow for decoupling of services that allows you to process events in a way that's a little bit more scalable and flexible and also allows you to replay data as is needed. When we think about the current state of a system, so back in the day when we were pretty much all just using relational databases and storing all of our data there, we were really looking more at the current state of data. So maybe that was what someone's current email address is or what their balance was in the bank. These things are all really important to know and are usually an integral part of our systems and the architecture of those systems, but they don't really tell you the full story. So knowing that a patient's temperature is 98.6 degrees, it may seem like it's fine, but there might be a backstory to that temperature that would allow us to make more educated decisions. So for instance, when we look at events, we will see the changes that happen to the state of our data, and then we can make decisions based on that. So let's say, for instance, someone spends $16 at Target.com. We have that in conjunction with other information about the amount of money that they've spent. So let's say, for instance, a customer spends $16 at Target.com, and then they spend $33 at Target.com, and then they spend $45 at Target.com, all within the span of like a minute. They're probably going to get notified from their bank that there is potential fraudulent activity. The only reason that we're able to do that is because we look at the event itself or the collection of events, as opposed to simply looking at the state, which wouldn't tell us that valuable information. So that's where the need for event-driven architecture kind of came along. But where did we come from architecturally? Well, in the past, we were storing all of our data in databases or data warehouses, right? And then we were using applications to connect to that data. And then we were using many different types of systems to integrate our data sources and our data sinks to our applications and also to each other. This worked okay, but it did cause some headaches. First of all, a lot of point-to-point connections, difficult to manage, really difficult to scale, because as you add more applications or more data sources or more systems in general, you have to add more point-to-point connections, and it becomes really messy over time. You also have this inability to store the data in any capacity while it's in flight. So you really only have your storage systems to store your data, and you're having these other technologies to just move data across, but there's no real easy way to do retention in the middle layer. And because of that, you have to have tools that are very specific. So it might be like an ESB, or it might be an ETL tool, but you don't really have a tool that can do multiple things. So you have to maintain a lot of different technologies. So we did have a lot of new types of databases and file systems and applications come along with the adaptation of big data. So big data saw a lot of a lot of new tech, things like Hadoop and Spark and different types of databases. So no longer were we just storing data in relational databases, but we had like document databases come about. We had caching, typical NoSQL databases. And so those created even more new complexities in trying to join the data between various sources, keep track of what your schema was doing over time. All of that became more difficult with the advent of new big data tools. So that's where Kafka comes in, or Kafka-like technologies come in, creating this middle layer that does multiple things. So it will keep track of your data as it evolves over time, also keep track of the schema so that as you are consuming from and publishing to applications or file systems or databases, you have a knowledge of how your schema is evolving over time. It also does a certain amount of stream processing. So all of that happens at the middle layer, and therefore you don't have to introduce new technologies every time that you want to integrate something into your data transfer layer. Okay, so as a sort of part two to event-driven systems, that's where this event model came to be, that's where the need came about. But how does that actually look in production, and what does it mean to have an event-driven architecture? And the answer is really that event-driven architecture can look like a lot of different things. So it doesn't necessarily mean one specific way of handling your data. There are a few options just depending on what your use case is and also where you are within your event-driven lifecycle. So the first, and I would say the easiest implementation of event-driven architecture would be event notification, which is essentially that you have systems that are notifying other systems of events that have taken place. They don't care at all about what the other systems do with that notification. They're just saying, hey, customer changed their email address, do with it what you please, sort of like a fire and forget type of system, really loosely coupled, which is a big plus because you have these different systems that can be swapped out sort of as you see fit. The systems are not super reliant on one another. And it's usually just a transfer of metadata. So if the system that's receiving this event notification decides that it wants to do something more with the notification itself and with the event that's happened, it usually will require that system to then reach out to the original system and require more information. Obviously, there are trade-offs here, right? This loosely coupled system, that's a really good thing in certain ways, but it also becomes difficult if you do need to track workflow. If your publishing system needs to know what happens to the data down the line, it can become a little bit messy to manage your data as it moves across your systems. The second sort of next step up would be event carried state transfer, which is similar to event notification in that, let's say there's a state change on one of your systems, you're notifying other systems of that change, but this time that notification actually carries the change with it. So it's not just access to metadata about the change, but it's actually sending the data across. This is even greater decoupling as systems are not reliant on one another. So instead of receiving metadata about a change and having to reach out to the underlying system, in this case, you would just get the data from the first go, and then your system can do with it as it pleases. So it is highly decoupled. It does also lead to lower latency because the system that's receiving it does just have the data on hand. And you also have lower load on your underlying systems. So your underlying system just sends out one event that has the data along with it. And then as many systems as want to consume it can do that. And they don't have to requery the underlying system. So it's lower load on the systems that are sending out the data as well. And then there's the holy grail of event-driven architecture, which is event sourcing. This is what everyone asks me about when they start thinking about event-driven architecture. And I would say that it's almost becoming synonymous in some ways with event-driven architecture, although it shouldn't be. But event sourcing is essentially that whenever a change is made to any of your systems, it's logged as an event. Those events are all stored within a single middle layer, so something like Kafka, and they're stored indefinitely. Because of this, system state can be rebuilt at any time from the event layer. And unfortunately, on the flip side, there's large amounts of storage required at the Kafka layer because Kafka is distributed storage, first of all. And second of all, if you think about it, let's say you have a database, a Teradata database, and it's storing only the state. And you have a terabyte of data. If you were to store every single event change that happens to get to that current state, which is what you're doing with an event sourcing, it's going to be much larger than you would need within your relational database layer. And finally, we have CQRS, which is really just what most of us would think of when we think about querying for data. It separates read and write so that every method is either a command or it's a query. And so Kafka can be used as the middle layer. So you'll write to Kafka, and then you would have to pull the data out of Kafka and write it to a database or other materialized view to be read. So those are pretty much your 4 options when you're talking about event-driven architecture, and each of them is just a little bit of a different flavor, but all use events to get their information. Okay, so going into a bit of an introduction to Kafka itself. So Kafka came from LinkedIn. The founders of my company, Confluent, actually built Apache Kafka at LinkedIn. They were running into some issues with scalability and point-to-point connections, the things we were talking about earlier. And they didn't think that there was really any tool on the market that addressed all of the issues they were running into. They were specifically having a hard time scaling out messaging systems and receiving really high throughputs. So thus came along Kafka. And Kafka allows you to store a large amount of data within the Kafka layer because it scales very well. As you start to reach disk capacity on your cluster, you can always add additional brokers to deal with the additional data that you're consuming. So because of that, LinkedIn had more than a petabyte of data stored in Kafka, over 4.5 trillion messages per day, 60,000 data streams, and it was the source of all of their data warehouse and Hadoop data. So it was really, really large scale deployments of Kafka running across many different industries. And honestly, almost any company you can think of is either using Kafka or is considered using Kafka. It just has really been adopted across the market. So what are some different architectural patterns that we see with Kafka? The first one, I would say the introductory use case to Kafka is database offload. So you have an old Teradata database sitting in your warehouse, and you want to extract the data from Teradata and put it into your data lake. You can do this in a few different ways, either using just a typical JDBC connection, or you can look at the change logs for more of a CDC type of fashion and stream the changes that occur on your relational database into data lakes for things like analytics and reporting. We also can have stream processing within Apache Kafka. So pulling, once again, let's say from like an underlying database, this could be a database file system application, anything that is currently running within your infrastructure, pulling various feeds from that underlying database, and then running stream processing on those feeds, either to do things like filtering, joins, aggregations, and outputting to a different materialized view or database or NoSQL database to do various types of analytics on top of it as well. You also have the ability, using something like Kafka, to transform the data and then use it in many different capacities. So I think something that is pretty unique to Kafka is that because it's an asynchronous model, meaning that the producers do not care about the consumers and vice versa, and because the data is stored on the Kafka layer for a set amount of time that you are able to choose, you have the ability to have many different consumers that plug into Kafka. So once you've made that transformation, instead of having to pull from your underlying systems every time a new system wants to receive data from them, you can instead just pull from the Kafka layer. So it makes it much more scalable, much easier to add additional sources and sinks of data. Okay, so what does the actual architecture of Kafka look like? Well, you do have producers and consumers, which on this slide are just referred to as writers and readers, right? And you're publishing to a Kafka cluster, which is made up essentially of a collection of immutable logs. So as you are writing to your Kafka cluster, you are writing to this distributed set of immutable logs, and then you have readers which connect to those logs and consume any set of topics that you choose. So it's scalable like a file system, right? And like file systems of the new age, it also is run on commodity hardware and scales to high throughputs and also high amounts of storage. And it's similar to a database because it does have strict ordering at the partition level. So in Kafka, topics are made up of a certain number of partitions where the data is replicated across those partitions. And within each partition, you have strict ordering so that you can maintain order of the data sitting within Kafka. And then you also have persistence at the Kafka layer. So like I said, you can set a retention period. Within Kafka, you have the ability to store the data indefinitely. So there is infinite retention that is possible at the Kafka layer if it's important that you have that event log for all of your data over time. But standard default is 7 days of retention. Because you have this immutable log of records, you have the ability to replay from different points within the log. Each new event that happens is what we consider an offset. And the offset of data tells you where you are currently consuming from. So you can reset the offset to an earlier time and be able to replay data from a specific point in time. It is distributed. So what that means essentially is that we have replication built into Kafka. It allows for higher fault tolerance. We have partitioning built in, which I mentioned. Partitioning really provides your durability on your cluster. And you have the ability to scale your Kafka cluster as you require more and more capacity, whether it's throughput capacity or storage capacity or CPU capacity. You can continue to grow your cluster by scaling and adding additional nodes. So this is the anatomy of a Kafka topic. So when you do have a Kafka topic, you have a number of partitions. So in this specific example, we have 3 partitions spread across 3 separate brokers. So you do receive high availability on your cluster. And then over time, as you produce to Kafka, it is always appended to the end of your log. So it's immutable, meaning that you can't decide to go back to a specific offset and reproduce certain data. So instead, what you do is you simply write the newest record, and it's written to the end of the log. Because of that, you really can replace state pretty easily. So I can, if I have an immutable log of records of all of my changes over time, I can reproduce my state at any given time because I know every change that's ever happened to the system. When it comes to consumption, you can have either a single consumer or a group of consumers to consume from a Kafka topic. So if you do have a single consumer, it'll consume from all partitions, and it will maintain its partition offsets, meaning that it will know exactly where it's consuming from. But if you have a group of consumers, then that group of consumers will share the workload. So if there are 4 partitions and you have 4 consumers, then it's going to evenly distribute the workload across the consumers. And each consumer will save its own offset and know where it's consuming from. Okay, so beyond just the standard pub sub and the base Kafka Core, which is that immutable log of records, there are a couple of additional tools that were added into open source Apache Kafka. So Kafka Connect was added back in the day. I think it was 0.8. Kafka 0.8 added Kafka Connect. And it is a no-code way of connecting known systems. Connect is a Java-based API, and it is essentially a framework for writing connections into and out of Kafka. There were also a number of connectors that were built on top of Kafka Connect by the open source community, by folks at Confluent, and also by a large ecosystem of partners to bring data into and extract data from Kafka. So these pre-written connectors, a lot of them are open source. You could go and download them today and start bringing data from your various data sources into the Kafka layer. And so the way that Connect works is it's essentially its own, either its own cluster or its own standalone workers. And the Connect cluster itself would provide for more failover. So within a Connect cluster, you'd have a number of workers, each of which had connectors that were living on it. And essentially, then you would have the failover capability in case one worker went down. Those tasks would fail over to another worker, and you would still have your workloads running smoothly. Whereas if you do a standalone Connect worker, meaning you have a worker, it's connected to a database or a file system or an application, and it's also connected to Kafka. It's made specifically for the workload that you're trying to bring in, and therefore, if there is downtime on that Connect worker, then you don't have the failover capability that you have within a distributed Connect cluster. We also have Kafka Streams, which came about in like the following release. It was 0.9, I believe. And Kafka Streams is once again a Java-based API, and it's really for stream processing. People use streams to do things like write microservices, and also allows you to do queries and transformations, essentially a key part of ETL. This allows for things like a 360 view into your customers, fraud detection, monitoring. So it's competitive with things like Storm, if you're familiar with Storm, or Flink, similar to those technologies, but it works specifically with your data sitting on the Kafka layer. So if you think about the Kafka Core, it's data that is put into various topics, which is then broken down into partitions. Whereas Kafka Streams, it has tasks. So it breaks down its processing power, essentially. So it processes over a number of tasks, and then it outputs its results to a Kafka topic. It allows for 2 different types of storage. So either a stream, which is a Kafka topic, essentially, and it, just like a topic, it's event-based. So each change that's made outputs a new response to the stream. So if one of the underlying systems has a change to it, a new log record will be added to your Kafka topic. Whereas a table is, think of it like a materialized view that's continuously updating as the changes happen, so that you can query that materialized view from external systems. We did also introduce KSQL. So KSQL is an abstraction layer essentially on top of Kafka Streams for doing stream processing, but using SQL queries. So think of it a little bit differently from like a standard RDBMS ad hoc querying, because you're not so much looking for a specific point in time, although that is available. Like pull queries are available with KSQL DB, but the reason it was built was more for stream processing use cases, meaning I can use a SQL-like language, but then I get the same stream processing results. And this just allowed for greater adoption of stream processing by teams that maybe don't have Java developers in-house. Once again, it works on the data that's sitting in your Kafka topics. And you can do things like filtering, joins, aggregations, windowing functions over that data to transform it and then publish the results to a topic to then be consumed by downstream systems. So some example use cases for KSQL would be things like filtering and cleansing, like we talked about. Data exploration, obviously, so just needing to see the results of your data, get to know your data, do a little bit of data mining. You also have the ability to enrich it, so you can join various data sources together and create an enrichment on your data. You can do some transformations across the wire. So as the data is flowing across, then you're doing your ETL-like functions. And then, of course, monitoring and anomaly detection are pretty key use cases as well. Okay, so a few things that I just wanted to touch on really quick in terms of what Kafka really looks like in production. So who should manage your Kafka cluster? I think this question is one of the most common ones that I'm asked by people in this space. And I think the real question comes down to, A, do you have people to manage your cluster for you? AKA, do you have Kafka experts in-house, or are you willing to hire them? Because that's the only way that you can really have a self-managed solution of Kafka. It does give you some key benefits. Let's say, first of all, that your workloads are on-premise. It probably doesn't make sense to have a fully managed solution that's sitting in the cloud when your workloads are on-prem, right? That's just going to introduce a lot of latency. Doesn't really make sense. Self-managed does give you also some more granular configuration control. So if it's really important to you to have a lot of control over the configurations at the broker level or the topic level, then the self-managed deployment might make more sense. There is also a higher security control on a self-managed cluster for obvious reasons, right? Your data is not leaving your environment, so you have ultimate control over it. You do also have a higher DevOps burden though, right? So when I was working at a company in the past where I was a big data engineer, I think is what they called us, but honestly, sometimes I felt like I spent 50% of my day managing Kafka. It is a pretty high DevOps burden when you're running a cluster at scale. There are various providers for this. So there is just open source Apache Kafka, which comes with, like we mentioned, the key features. So Kafka Core, Kafka Streams, and Connect. And then there is some additional tooling within Confluent Community, which is once again an open source download. And then there is Confluent Platform, which really Confluent came about and built support on top of Kafka, but also built additional IP, so additional tooling. You also have the ability to go a fully managed route. Fully managed Kafka is faster time to live, obviously, like everything that's managed. A lower operational burden in general, and maximizing your uptime, but unfortunately you do have lower operational control that balances out that burden. So a lot of times with fully managed solutions, you don't have the ability to change certain configurations at the broker level. So you are sort of at the mercy of the provider that you choose. And typically you have less insight also into what's going on within your cluster. So there is less monitoring that's provided a lot of times with fully managed solutions. Some providers there, so if you're an AWS shop, AWS did come out with a managed service for Kafka, or MSK. MSK is really like an infrastructure management of Kafka, more or less, and allows you to more easily spin up Kafka clusters, but you still have a little bit more control over the settings on your cluster, and you do have a little bit more operational burden as well. Whereas something like Confluent Cloud is a little bit more of a fully managed service. And then you have companies like Heroku who will just set up and deploy a Kafka cluster for you and do the management piece for you. So that's probably the most like high touch management capability. Another thing that I get asked about a lot is logical isolation, or when to logically isolate versus when to physically isolate. So if you have various teams, something that's really great about Kafka that comes natively to Kafka, and additional tooling was built to support this, you have the ability to isolate within a single cluster. Typically what we'll see people do is they'll isolate their resources by topic. So they might have, say you have 5 different teams internally that are running Kafka. You can isolate them out by giving them each a set of topics that they can use. And then you achieve security across those topics using something called access control lists. And access control lists in Kafka essentially allow you to control who has access to which clusters or which topics, and who is able to either read from or write to or do various operations on your Kafka cluster. Because of this, there's typically not a need for separate clusters. You do have the ability to set up quotas. So there's a lot of resource management that's built into the Kafka layer. You can physically isolate in certain use cases. So let's say, for instance, first of all, you want 2 separate clusters, one on GCP and one on AWS. In that case, obviously, you would have multiple different clusters and you might replicate some data between them, but they might just be completely separate workloads, and that's fine. You also might want to physically isolate when you have various customers or consumers in general that have specific needs that are separate from those of your other internal or external stakeholders. If that's the case, then perhaps a second cluster is required. But in general, Kafka is pretty natural at logical isolation. And so it tends to be a decent fit. And then I think the third most common question I ever get is, do I really want to store my data infinitely at the Kafka layer? And my typical answer, honestly, is no. And I know it sounds crazy to say that as someone coming from Confluent or a Kafka company. But typically, as we mentioned before, if you have a ton of data and it's changing all of the time, it's going to require a large amount of storage on the Kafka layer. Is it possible? Of course, it's possible. It's becoming even more possible as time goes on because there are cheaper storage options. Tiered storage has been introduced to Confluent platforms, so you can archive data as it becomes less useful over time. And there also is this concept of compacted topics within Kafka, which essentially means you're just storing the state. So for each key value pair that is a message, it is storing only the most recent key value pair. So that's what a compacted topic is. Because of those 3 kind of evolved features, you will see people, I think, storing more and more data on the Kafka layer so that it can be more of an event sourcing model or single source of truth. But for the most part, unless you have a use case that highly favors streaming capabilities, it's probably a good idea to have a secondary storage layer. So whether that's a database or a data lake or a data warehouse or whatever it is that you use in-house to store your data indefinitely, and then only maintain the subset of data that you need to be able to replay from at a moment's notice on the Kafka layer. Okay, so that's what I had for today. I hope that was useful, and I think that there are some questions potentially. I wanted to point out really quickly that I also included some resources, so I'm happy to share these slides with the group. But I included some resources just in case you're interested in reading more about Kafka.
All right. Well, thank you so much, Amanda.
Yeah.
I think we have a question in the YouTube chat. Arturo?
Um, so the question is from Siddharth Bidikar, and the question is sending off a large message like 10 to 20 megabytes possible on Kafka? And if not possible, how to take care in case of such requirement while using Kafka?
Yeah, so no, that's actually not possible within the Kafka layer. I don't want to speak out of turn, but I believe the default max message size is like a megabyte or 2 megabytes maybe. And it's not recommended that you change that and go above that. I think you can pretty safely change that up to about 8 megabytes, but it would be really irresponsible to go above 8 megabytes for a max message size. What we tend to see people do if they do have large messages like that they need to send across is that they will send over a reference to the message, and then they'll have the message stored somewhere else. So then the receiving subscriber can take the metadata and pull from where the message is stored. That's what we tend to see people do.
Cool. I have a question, Amanda.
Sure.
So from the architectural perspective, when should you choose between Kafka and a traditional messaging system like RabbitMQ or IBMQ? Is just based on volume, or there are other reasons?
Yeah, that's a great question. I might want to send you with some resources like after the call, but I'll be honest with you, for standard messaging use cases, if Rabbit's working fine for you, that's fine. Use Rabbit. I know lots of people who use RabbitMQ, and they're totally fine. But I also talk to customers that run into problems when they try to scale the solution. So as they get higher amounts of throughput, they kind of reach the top capacity limits of Rabbit, and that's where they would want to go to something like Kafka. So it's really more like when you're trying to build this out to be something that's highly scalable, that's where Kafka comes into play.
All right, cool. Arturo, Orlando, do you have questions?
I have one. You talk about full self and fully managed instances. What has been your experience with clients migrating from one to the other? For example, I mean, what will be a good use case of, we were trying to do this and we were struggling with this type of technology, and Kafka was the right fit there?
Totally, yeah. So honestly, I think that one of the major reasons I see people migrate from a self-managed to a fully managed is when they make the move to cloud ecosystems. So if they were traditionally on-prem, so they were running Kafka on-prem to migrate their data between their various systems on-prem, and then they want to start implementing cloud use cases. When they make the move to cloud and they move to more managed services in general, so whether it's also moving to like a managed Elasticsearch or various managed services on AWS, then they start to think about using a fully managed Kafka service, because even when people have a lot of Kafka experience, it can still be difficult to manage in production. You're having to do a good amount of DevOps to keep it up and running. Just at scale, that's typically how it goes. So it saves them a lot of time and in the end, money, right? And not having to have their developers spending so much time managing the infrastructure.
Yes.
And yeah, on the same, following the same question, even if you have your applications running on-prem, but your messaging system will be probably fully managed outside of your company. Is that a good approach, or?
So if you're using a fully managed service on the cloud, whether it's like MSK or Confluent Cloud, and then your workloads are all on-prem, that's kind of an anti-pattern just because of the latency hits that are going to be incurred by doing that. So typically, if all your workloads are on-prem, you'll have a Kafka cluster on-prem. If you have some amount of workloads on-prem and then you have some on the cloud and you want them to be able to communicate, then I see a lot of people hosting on the cloud and pulling from their on-prem system. So it depends use case to use case, but if the latency is going to be introduced anyways when moving the data, then it can make sense to fully manage. But what you wouldn't want to do is like send it to the cloud and then send it back, because then you're just going to get hits over the public internet.
Okay, I have a question in Slack. Gopi Sant is asking, are there any tools in Kafka for data quality, since you mentioned that some part of the ETL?
So for data quality, I would say not specifically data quality. There are some amount of governance tools. So like schema registry is a big part of Kafka in general these days, open source Kafka, and also the Confluent platform. And that can allow you to manage your schemas and implement things like forwards and backwards compatibility and watch as they change over time, and can work with various serialization formats like JSON, Avro, and Protobuf. But yeah, I think if you want to implement a real full data quality solution, that would have to probably be through a third-party provider.
Okay. Arturo, I think you have another question there in YouTube.
Yes, it's also from Siddharth Bidikar. If we use Kafka, do we need to also be dependent on Zookeeper?
As of right now, yes. Zookeeper is still fully integrated with Kafka right now, and it's a necessary component. I will say that that was one of the initiatives for this year. It was announced at Kafka Summit at the end of last year that they're trying to decouple Zookeeper from Kafka, so you don't have to use it, which is super exciting for anyone who's worked with Zookeeper in the past. And those efforts are being made, and it slowly is happening, but we're not there yet.
Okay, I have, this is one of my questions. What is the pricing model? Probably, I'm not sure if you're familiar with that, but for the cloud service of Confluent, how do they bill? They take care of the how many VMs or servers are you going to have in the cluster and all those things? What's the pricing model?
Yeah, so it depends. There's like a shared service of Confluent Cloud where you're like sharing resources with other customers, but you're logically isolated from them. And that one's billed just like per use, essentially. And then there's a more sophisticated type of cluster, which is a dedicated cluster spun up specifically for you. So that one comes with a higher like base cluster cost, since the resources are just being used by your company. And it's essentially billed on the number of brokers that you're provisioned for. And then there's also the variable costs of what data you're using and storage you're using.
Sounds good.
Did you hear me? Sorry, I think I froze for a second.
Yeah. But I think I heard the answer. Thank you, Amanda.
Okay.
Yeah, there's another question from Doug Jones. I'm not sure I understand it, but I'll just pass it on. It says, I've seen Kafka is guaranteed at least once delivery. Is there a built-in mechanism or common pattern to make dedup easy?
Yeah, so I'm assuming dedupe or deduplication, I'm assuming. Yeah, so there is exactly once delivery. It actually was introduced for the other Liberty Kafka clients as well, so the Java client, and then also like the Python, .NET, C and C++, and Go clients all have the exactly once semantics now as well. I wouldn't say that it's easy to implement, honestly, but it's available. And if you want to ping me on like LinkedIn or something after the call, I can send you some resources on how that's implemented, the Kafka layer.
Cool. I have another question in Slack. Gopi Sant is asking how to experiment with Kafka in a typical development environment.
Can you expand upon that question? Are you asking about CI/CD or?
Well, he followed up saying in relation to IDEs. I mean, to an IDE. I don't know if your development environment had any particular benefit of using an IDE, or I don't know. That's how I understand the question.
It's up to you. So typically the main things you're working with are your clients for writing data to Kafka. We're at the Java usage groups. I'm assuming that most of you are probably using the Java or Scala clients, right? And then you also have development of your connectors, which is once again Java-based, and then development of Kafka streams, which is once again Java-based. So typically it's just whatever IDE that you normally use with your Java development, you would use for this as well.
And Gopi, we're raffling a JetBrains license, so stay tuned.
True, there's a question from Ajay in the chat.
Yes. What are the cases for Kafka versus Solace?
Versus Solace? Hold on. I'm not super familiar with Solace, to be honest. Yeah, so Solace, it looks like it's a pub/sub messaging system. Let me get back to you on that. It looks like it would just be like, typically pub/sub is one piece of what Kafka does. So that's the core immutable log of records that everyone sort of knows Kafka to be. But then it's more than just pub/sub. So Kafka also does like transformations, and it also does connections to external systems. I'm not familiar enough with Solace to know if they have those capabilities, but I can look that up and get back to you.
Yes, so Gopi clarified on the question that he asked about the development environment. He was referring to the IDE, if there is a Kafka connectors in IntelliJ or something like that. I'm not sure if you know that.
No, I don't, but I would assume that because Kafka Connect is written in Java and Streams is written in Java, that it would play well with Java IDEs like IntelliJ or whatever you may be using. I would expect that it would play very well with that.
Yeah. Well, I had one last question from me. So
Okay.
I didn't know about KSQL. So I just wanted to ask you, with the clients that you work with, have you seen any real life examples that you can give us to use KSQL?
Yeah, there's a lot of people using KSQL. I would say the most popular use cases for it are like either filtering out data. So I get this data stream of information from one of my underlying databases, and then I want to filter and just take a subset of that data and send it to an external system. That's one of the most common. And the other common use case is aggregating data. So let's say you have this application that is sending real-time data to Kafka, and then you also have an underlying database and you need to pull some amount of, let's just say, for example, customer information from that underlying database and connect it to your data that's coming in real time. That's a pretty standard use case that I see people doing, enriching their real-time data with data that's sitting at rest.
That's cool.
Yeah.
That's cool. All right, I think we don't have any more questions. So I'm not sure if you have a question that you can think of. I have one, but it's super easy. But if you have a question, it will be cool to...
Make it easy. Make it easy. We don't want. We want an answer. We want someone to win the raffle.
So just to
make it really easy. Okay. So I guess coming from that slide, the slides.
Time out. The answer should be published on YouTube, because we have people on Slack and on YouTube, but not everyone is on Slack. So the answer should be published on YouTube and on the live chat, and whoever answers first and correct gets a JetBrains license.
Okay,
sorry to interrupt.
We do have a last-minute question before we proceed with the raffle. This is from Arati Shrishta. What is the purpose of replication in Kafka? And how...
Up to how many instances?
Yeah.
Okay. Yeah. So essentially, the replication is for the same reason that like distributed file systems replicate their data, so that if you do have downtime, let's say you have 3 Kafka brokers and you're replicating your data across those 3 brokers, so your replication factor is 3. If you write the data to 3 different places and you have a broker that goes down, then you can still access the data from 2 different brokers. So that's the main reason. 3 is what I would say is the default or the standard of replication, but you can do more than that. It's I would say best practices is probably around 6 for a large cluster. But yeah, it depends on your use case, essentially.
Yeah, does it increase availability?
Yeah, it increases your availability on your cluster. Mm-hmm. You also can do like a full replication. So the replication internally built into Kafka already provides that high availability. But if you want a full replication of your cluster, you can do that using external tools like Mirror Maker or Replicator. Have a second cluster of Kafka. essentially do disaster recovery so that you can fail over an entire cluster if need be. So we have customers to do that as well.
Okay, cool.
Yeah, so there's like internal replication and external replication, just depending on how necessary it is for you to be able to fail over, right? So.
Yep. All right. Well, there are no more questions. So let's go with the question for the raffle. So everyone ready? Just again, send your answer to the YouTube stream channel, and the first one to answer correctly is the winner for the license. So, what's the question?
Okay. So do you want me to do mine?
You have one, yeah. Let's try that one.
Sure. Yeah. So the question I was thinking of what's the main difference between KSQL and Kafka streams? Is that too easy?
No, that's good. That's good.
Okay.
We'll see if we get an answer. Last time we didn't get any answers.
So we have a slight delay. I could cheat and just put my answer there. Now that you mentioned, is there any performance hit for using KSQL?
Slight, right? So it's the same performance hit as if you had like a producer. So you will see a little bit, but typically your clusters are co-located, so it's not like a huge latency hit to pull off and do aggregation within KSQL or Kafka streams.
Okay, no answer so far.
No
Let's wait a few more seconds. No, I don't think we have any winners for that question. Oh, there you go.
It couldn't get easier than that, really.
Okay, so Doug Jones is the first one that replied, and he's saying KSQL doesn't require Java developers to query.
Yeah, that's a good answer.
Cool. So Doug, you're the winner, Doug. So how do we do it?
I know Doug. He works with me.
Perfect. Okay.
And we didn't cheat. I mean, he got the answer.
Okay.
Yeah, I'll make sure that Doug gets his JetBrains license.
Yeah. Okay. Congratulations, Doug. Well, I just want to thank everybody for joining today. Thank you very much, Amanda, for the great talk. And we'll see you next month, I guess. Right? Any closing comments, Orlando?
No, thanks, Amanda. Thanks, everyone that joined the conversation. Next time, I mean, well, we haven't published the topic, but I mean, next month we're gonna have. I think we're planning something exciting, and bring your friends, bring your family. It's a safe place, COVID-free, so bring everyone.
And just a quick reminder that if you want to give a talk, no matter how simple it is, we are welcoming everybody from the community. So reach out if you want to give a talk.
Yeah, cltjog.org, and there you can find everything there.
Awesome. Thank you very much, guys.
Thanks.
Thanks, everyone. Bye.
Thank you.